Today we're going to be focusing on graphing lines. The first form that we're going to look at is slope-intercept form. The reason that it's called the slope-intercept form is because it has two values that are filled in. The slope, which is the rise over the run, or that rate of change that we talked about in the previous unit, and B is the y-intercept, where it crosses the y-axis at. So when we're looking at a line in slope-intercept form, the first thing we want to do is recognize what is the slope's value. In our example, it's -3/4. And what is the y-intercept's value, which is 2. When we go to graph, we're going to start with the y-intercept. The y-intercept is where it crosses the y-axis. So I'm going to go over to my y-axis and place a coordinate at the value of 2. That is my beginning point. So from there, I'm going to use my slope next, and that's going to be my movement. So my slope is a negative value, so I'm going to go down 3 units and over to the right 4. So I'm going to go down 1, 2, 3, to the right 1, 2, 3, 4. I can continue this pattern if I want to get a few more coordinates. Down 1, 2, 3, to the right 1, 2, 3, 4. That is the same as going up 3 units and backwards 4. Since it is a negative slope, it does trend in the negative direction, or it is going downhill. Notice that I did not, so a common mistake that students make is that they go 2 negative directions when they see that it's a negative slope. So if I went down 3 units, 1, 2, 3, and backwards 4, 1, 2, 3, 4, the 2 negative directions end up making a positive slope, since it's going uphill. So make sure that if every time you have a negative slope, your line is going in the negative direction or downhill. So what if a line's in standard form, not in slope-intercept form? So we did literal equations where we solved to get a variable by itself. It's the same idea. We want to get the variable of y completely isolated. We're going to make this line in just slope-intercept form and graph just how we did before. So my first step is to move the -4x over by adding 4x to both sides. So I have 2y is equal to 4x minus 6. I cannot combine these together. They are not like terms. And then I'm going to divide every term by 2. So y is completely isolated. So y is equal to 2x minus 3. Then we repeat the same process. So I need to identify my slope and my y-intercept. So my y-intercept is -3. That is the starting point on the y-axis. So I go down to -3. And then my slope is the value in front of x, which is 2. Now we do not have a fraction like we did in the previous example. So movement-wise, I'm going to go up 2 spaces and over 1. Up, rise 2, run 1, rise 2, run 1. The reason we run 1 is it doesn't change the value of 2 if I place a 1 underneath, because 2 divided by 1 is just 2. That is the same as going down to backwards 1, because if we move in the negative direction twice, it ends up making a positive slope. So I am trending or going uphill in the positive direction. The last part of this unit is asking for the intercepts. So the intercepts are where we cross the x and the y axis. So the x-intercept is where we cross the x-axis. The y-intercept is where we cross the y-axis. Now, no matter where I go along the x-axis, whatever coordinate I choose, the y value is always going to be 0 because I don't go up or down. Same is true with our y-intercept. Wherever I go along the y-intercept, my x value is going to be 0 because it doesn't move left or right. So we want to use that information when solving for x and y intercepts. So if I'm solving for the x-intercept, I know that my y value is 0. So I'm going to substitute 0 in for y and solve. So when I simplify, 5 times 0 is 0. So I'm left with 3x is equal to 30. And my x value is 10. So it crosses the x-axis at the value of 10. I can write that as a coordinate, 10, 0. When I solve for my y-intercept, my x value is 0. So I'm going to substitute 0 in for x this time. 3 times 0 is 0. So I'm left with negative 5y is equal to 30. Divide out by negative 5, and my y-intercept is negative 6. I can write that as a coordinate, 0, negative 6. So graphically, my x-intercept crosses at 10, my y-intercept crosses at negative 6. That also helps to create a graph because it only takes 2 points to create a line. Solving when it's in slope-intercept form, there is a little bit of a difference, but the same exact process. So if I'm trying to find my x-intercept, that means my y value is 0. So I substitute 0 in for y and solve. So I need to isolate x, so I'm going to add 8 to both sides. Divide out by 4, and my x-intercept is 2. I can rewrite that as 2, 0. For my y-intercept, since this is in slope-intercept form, I actually know that it's already negative 8. So if you recognize it's in slope-intercept form, then you can just use the value of 0, negative 8. However, if you don't recognize it, that's okay. When I go to find the y-intercept, I plug 0 in for x. So I have y is equal to 4 times 0 minus 8. Once I simplify 4 times 0 being 0, I do get that my y-intercept is negative 8. So graphically, I have 2 coordinates, one at 2, 0, one at 0, negative 8. It takes 2 coordinates to create a line.